The following content is created by Dr. Avitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below.
Welcome, ladies and gentlemen. I'm Dr. Avitech, and in this video, we're going to be solving this very problem. It says, obtain the half-range sine series in the nth term for this very function. Now, the first thing we want to do is to understand that we're looking for the odd extension of this function. Hence, we're only going to be finding b sub n because the Fourier series will be containing just the sine terms. So we only need to find b sub n. Now, b sub n, the formula for that is 2 over L, since we're dealing with an odd function, 2 over L, integral from 0 to L, f of x sine n pi x over L dx. Oh no, that should not be a partial derivative, dx. Okay, so this is what we have. And the next is the function 0, the range 0 to L was broken down into two parts. So we have 0 to L over 2 and L over 2 to L. So we're going to break this down also. So this will become 2 over L. Then we have integral from 0 to L over 2 f of x sine n pi x over L dx plus integral from L over 2 to L of f of x sine n pi x over L dx. Okay, now what is f of x? What is f of x when it's from 0 to L over 2? From 0 to L over 2, L of f of x is x. So this will be 2 over L. Then we have the integral from 0 to L over 2. F of x is just x there. So this is sine n pi x over L dx. And then plus this one, the integral from L over 2 to L, f of x is L minus x, sine n pi x over L dx. Now, definitely, we need to use integration by parts. So this will be 2 over L. If you notice, L was not specified, so we're going to leave it like that. L was not specified, so we're going to leave it like that. Then, to integrate this first part, this is x, so we're going to write x. Give some space, differentiate x, you will get 1. Now, this is sine. We're going to integrate sine. So to integrate sine, we're going to get minus cos. Then you put n pi x over L. Oh, okay. And you must divide by the derivative of the bracket. So you differentiate this bracket, you get n pi over L. That's n pi over L. Close this up. Now, this whole bracket here, you need to integrate this bracket again. So, to integrate this bracket again, this is minus, so you're going to write minus. This is cosine. When you integrate cos, you will get sine. Then you put in your angle, n pi x over L. Then divided by the derivative. When you differentiate this bracket, you will get n pi over L. Now, that n pi over L will make this very n pi over L to give us n pi over L all squared. And the correct sign for this will be plus and this will be minus. And our interval is 0 to L over 2. That's what we have. So this is for the first part. Let's come to the second part. So this is plus. For the second part, we have L minus x. So this will be L minus x. Now give some space. Differentiate this L minus x. You're going to just get minus 1. So next, this is sine. You're going to be integrating it. Now, since this and this is the same, that means this bracket will repeat itself. So let me just save myself this stress. Minus cos n pi x over L divided by n pi over L. Close that up. And then for this part, let me adjust the minus 1 that was here. Then this will be minus sine n pi x over L divided by n pi over L squared. Okay. Now the correct sign for this one will be plus, this will be minus. And then our interval is L over 2 to L. This is a lot. That's a lot. But we could do something. We could do a lot of things. All right, so let's see. Let's see what this is going to be. Let's simplify first this sign. Let's simplify this sign. Now this is minus. This is x. So this will be minus x cos n pi x over L divided by n pi over L. Minus times minus is plus. Then this is sine n pi x over L divided by, when you expand this will be n squared pi squared over L squared, from 0 to L over 2. So we have, and then plus L minus x. This is a minus, so let me put the minus here. That's minus, then cos n pi x over L divided by n pi over L, minus, 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 that's minus. So this is minus sine n pi x over L divided by n squared pi squared L squared, from L over 2 to L. All right, so this is the time, or this is the part where we'll put our limits. This is when we'll put our limits. Okay, now first of all, this is x over L. Let me kind of make life easy. This is x over L, and this is L over 2. So if you have x over L, that's x divided by L, and you want your x to be L over 2. So this will be L over 2 divided by L. So this is kind of L over L. So this is L over 2 times 1 over L. So that means you're just going to be getting half. That's what that means. You're just going to be getting half. So this will be 2 over L. And then this is minus x here will be L over 2. So this is L over 2 cosine of, this will be n pi over 2. Now why would it be n pi over 2? Remember that previously you have n pi x over L. So if you put your L over 2 here, the L will cancel L, but the over 2 will remain. That's why we have this. That's why this is 1 over 2. So you must have that over 2. Then divided by n pi over L. Then for this part, let's put that in also. This will be sine n pi over 2 again. Then divided by n squared pi squared L, okay, over L squared. Now this is for the upper limit. This is for the upper limit. Minus, for the lower limit, anywhere you see h, you're basically going to be putting 0. Now let's save ourselves some stress. If you put 0 here, this is x, right? So 0 times everything here will give us 0. This is x, so when you put 0 here, 0 times this is 0, 0 over this is still 0, so this is gone. This is sine. When you put 0 here, n pi times 0 is 0. Sine 0 is just basically 0. So everything here is gone. So I want to take this out. So no need for me to put my lower limit, because I found out that it's going to give me 0. Next, let us put in our L here. So this is the time for our upper limit. Let's put in L here. Sometimes you just need to kind of, should I say, see into the future when it comes to stuff like that. So this is minus. Now for this part, let me do it like this. Hold on. This is L. If we should put your L here, minus L minus L is 0. L minus L is 0. L minus L is 0. Okay. 0 times this will still be 0. So everything here is 0. Now when you put your L here, L over L is 1. 1 times n pi is n pi. Sine of n pi is still 0. So you see that that's gone, right? That's actually gone. So everything here will just be 0. So the only useful one will become L over 2. L over 2 will be the only useful one. But be careful, however. You know that when doing your limit, you need to say upper limit minus lower limit. So you have to be very careful here. Now I notice that there's minus here, there's minus here. So I could actually say, let this minus come outside. This becomes minus, then open bracket. Since this is minus and this is minus, I factorize out the minus. So this will now be positive. So it will become this plus this. So we had 0 plus 0 for the upper limit. If you remember, when you put in your L here, L minus L is 0. So that's 0. Now I'm having plus because I factorized out the minus. So this will be plus. And then sine n pi is 0. Then minus. For the lower limit, let's put in L over 2. This is x. So this will become L minus L over 2. L minus L over 2 is L over 2. That's L over 2. And then we're going to have cos n pi over 2. We've kind of explained why it will be n pi over 2. Then divided by what will be left here will be n pi over L. Okay, so this for this guy. Plus, now for the lower limit, let's put in L over 2. So this will be sine n pi over 2 divided by n squared pi squared over L squared. Okay. Yep, I've closed that up. Let me see. Hold on. Wait a minute. Okay, minus. Yeah, this is the lower limit part. Yeah, that's the lower limit part. And then close this up. Okay. This is a lot. Okay, so this is 2 over L. Then we have, I could expand this to then become minus L over 2 cos of n pi over 2 divided by n pi over L, then plus sine n pi over 2 divided by n squared pi squared over L squared. And now let's kind of do something. This is negative, right? This is negative. So minus here will give us plus. So this will be plus everything here. That's L over 2 cos n pi over 2 over n pi over L. And then plus sine n pi over 2 divided by n squared pi squared over L squared. Okay. All right. Now, if you look at this carefully, you'll notice that this and this are the same thing with different signs. Since they're the same with different signs, it means they will add up to 0. So this and this is gone. It will add up to 0. Now, what's left is these two guys. Now, since they have the same sign, it will become double of itself. So this will become 2 over L into 2 sine n pi over 2 over n squared pi squared over L squared. Yeah, like it will become double of itself. Okay, now what I'll do next is these two and these two can times. So this will become 4. So that's 4 divided by L with times this. So that's L times n squared pi squared over L squared. Then what's left is sine n pi over 2. Okay. Now this over L squared can go to the top. So this is 4L squared over L n squared pi squared sine n pi over 2. Now the L squared can be cancelled by this. So this becomes 4L over n squared pi squared. Then we have sine n pi over 2. Now, sine n pi over 2 behaves in a particular way. Sine n pi over 2 behaves in a particular way. So here's the behavior of sine n pi over 2. When n is even, sine n pi over 2 is always 0. It's always 0 when n is even. Always 0. Next, when n is 1, add 4 to 1, 5, 9, add 4 again, 13. When n is of this type of numbers, sine n pi over 2 will be giving us 1. Then when n is 3, 7, 11, 15, sine n pi over 2 is minus 1. Yeah, so this is what we have. So this, I'm going to just leave it like this. So let's find our Fourier series. So f of x is equal to the sum from n equal to 1 to infinity of b sub n sine n pi x over L. So this is the sum from n equal to 1 to infinity. Now b sub n is this. So this is 4L over n squared pi squared sine n pi x over L. Now what is the constant here? 4L is a constant. Oh, hold on. I've not put in my n pi over 2. Bracket sine n pi over 2, then sine n pi x over L. Okay, so the constant here will be 4L over pi squared. So this will be 4L over pi squared. Then the sum from n equal to 1 to infinity. What will be left here will become 1 over n squared. Look at it this way. 4L is outside already, so there must be a times 1 at the top. That's this one here. Divided by pi squared is outside, so what's left is n squared. Then this is sine n pi over 2, then sine n pi x over L. Now, if the equation says leave your answer in terms of n, this will be your answer in terms of n. That's your answer in terms of n. But let us say you're asked to expand to find it up to maybe the fourth non-zero harmonic. So what we're going to do is to say this is 4L over pi squared. Now let's expand. Let's say n is equal to 1. 1 over 1 squared is still 1, and we know that 1 times anything is that same thing. Also, if n is 1, sine n pi over 2 is 1. So this bracket is still 1. So let's come to this place. This will be sine n is 1. So this is 1 pi x. So we're just going to be having sine pi x over L. Then next will be 2. But when n is 2, that's an even number. That's an even number. So sine n pi over 2 will give us 0. So that's just, everything will be 0. So let's go to 3. When n is 3, we're going to be getting minus 1. So this will become plus 1 over 3 squared. But this is minus 1. Yeah, so let me just put this plus as minus. Then this will be sine 3 pi x over L. So next will be 4. But 4 is not going to work out because 4 is an even number, so this will be 0. So let's go to 5. When it's 5 is 1. So this is plus 1 over 5 squared sine 5 pi x over L. Next will be 7, but that will be minus. It's minus because when n is 7, we have minus 1. So this will be minus 1 over 7 squared sine 7 pi x over L. And then just like that. So this will be the final answer to the equation. And this will be all for this very video. I'll see you in the next one.